All right. All right, class. Welcome to Monday. Happy Monday for the recording. We are continuing 1.4. We did have questions on the homework for 1.4 since we were able to start it. So with number 1 and number 3. Cool. Okay, number 1, let's take a look at that one real quickly here. It says, just tell me if the relationship here is a function or not. So this is 1.4 homework, just the first view of it here. Let me recreate the problem itself. It says -2 goes to 5, -1 goes to 8, 0 goes to 6, 1 goes to 6, and 2 goes to 7. That's our relationship, or sometimes called relation. Question, is this a function?
Yes.
Absolutely. Bless you. This is a function because there's no repeating x's that go to different y's. So if we went like this, if this -2 also went to a 6, then we're in trouble. You can't have an x go to 2 different y's. You can't have you at 2 p.m. be at school and on the Cal Poly campus. Someone's lying. Okay, fine.
Why?
Let's see, the campus itself, I think it would be still called SLOCA, right? Even though the owners of it.
Yeah, Cal Poly campus ends at the horses. This is SLOCA campus.
Yeah, even though the owner of it is Cal Poly, still the property is
But when you go
SLOCA
to Cal
campus.
Poly, then you can say that you're on Cal Poly campus and on Cal.
Just have to cross this street category. Okay, we good there? Does that make sense? So X can go to 2 different Y's, not cool. So this is, let's see, National League. And we have the Cubs, the Pirates, and the Dodgers. And so this is, which is true, the National League, the Cubs, Pirates, and Dodgers are in the National League, but is this a function? Not a function, right? Because the domain is actually going to 3 different sets. Not good. So not a function here. There. And this one is a function. Okay, so that's where you guys to get going, starting on the homework here. We're good? Jam, let's go with the rest of it here. So let's review real quick here. So this is, we did it by points, right? First of all, we did it by mapping, didn't we? Got to go back because it is Monday, right? Like, man, we forgot a lot of stuff. So 1.4 talks about how we think about something called functions. Super duper important word. We use it a lot. This is the basis for algebra. If you think back to your Algebra 1 days, you spent most of the year looking at linear functions, right? Lines. And I think you also did polynomial functions, right? Where you like x squared, right? And x cubed. And then I think you guys did something called rational functions, which are like fractions, right? You got polynomial here divided by another polynomial. So if you think of like your days in algebra, you should think of like, I learned linear functions. Next, I learned polynomial functions. Next, I learned rational functions. Anybody remember something called radical functions? Stuff that has like this. I should make like a board of like review of algebra board, like a huge thing that would actually make sense. That's right. Yeah, it was 2 years ago too.
3 for some of us. Okay.
So we have radical functions, and then did you guys touch on something called exponential functions or no? No. Okay. So your knowledge consistory is, or consists of, linear, polynomial, rational, and radical so far. We're good? And so after we do the graphing stuff, we'll actually go on from there. We'll do exponential functions in chapter 3. So we'll just keep on going. I think so.
Oh, wow.
Okay, mapping. I think we just did this on the homework, right? Function, function, not a function. Jam. Then we did it by points themselves, and we just looked at the whole concept of you can't have this happening, right? You can't have 1 going to 2, 1 going to 3, not cool. Next, we did it by equations. If you can solve for y, and at that point, as you solve for y, you can logically deduct the fact that if you plug in a single number, you're going to get out a single number. So this works, that's just fine. This works, that's just fine, because you could square a number, still subtract and take a negative of it, add 3, that's fine. This is our problem. When you solve for y, if you get a plus and minus in there, no, because once you plug in a number, you're going to get a positive number out of it, and you're going to get a negative number out of it. Now you have 2 numbers. Now you plug in one x, you get out 2 different y's. So here is our equation stuff that can't work. Okay, so let's talk about functions, since this is called function notation. There it is. Noah's going to know what he did in chapter 2.
Yay. Now I'm going to actually understand what the world they did there.
Because you did the homework without even knowing it then. Okay, let's go for it here. So f of x. F, this guy right here, this gives you the name.
Yeah, I've seen something very similar to this.
Name of a function. So we can call, whenever we name a function, we can just call it by the first name. So f is normally used because it's f for function. We also use g of x is fine. Usually in mathematics, we use g of x, we use h of x usually for like generic functions. Now, when you get into specific functions, like you're going to do economics and stuff, what do you guys say? What do you think that function is about? For economics. Communism. Okay, that's cool. Economics has to do with money, not social structures yet.
You mean not yet, capital
Ooh, that's capital. Why did I ask? Why did I ask?
You should have just said you asked.
Have you ever called kryptonite?
No, it doesn't.
And then you have the all night kryptonite. It's K, right?
Okay, I was gonna say cost.
Oh, yeah. That makes
Okay. Cost, okay. Better than kryptonite. Okay, how about so cost and what do you guys say? Cost and what? What's P of X? Price. Oh, cool. Price is a good one. Profits is another one. Profits. R is for revenue. I won't even ask anymore. Just revenue. So then there's actually, oh, this is interesting. With naming of functions, a capital C is really different from a lowercase c. Those would be technically 2 different functions, right? So if you have capital C, then you have this one. Those are actually 2 different functions. Okay, so naming, we're good? Naming of functions. This guy is called the independent variable. Okay, so I'll write it better than my chicken scratch. Independent.
This is science class all over again.
Variable, just a little bit here. So independent variable means you are the one plugging in the variable. You can plug in the 3, you can plug in the 12, you can plug in the negative 24. We good? All right, and this piece right here, we call is the condition. So what is it doing? What are you trying to do with that function? Okay, so some examples here real quick here before we get started. If you want to write these down, that's fine. If you just want to take a look at it. So another generic function, g of x, just g of x. There it is. 2/3 x squared, that's fine. And then this value of x can change. I can make it whatever I want. So let's say it's h of m. The only thing is if I switch that, then m has to be part of my variables right here. Are we good? Yeah.
So m always has to be used as a variable.
So whatever my variable is, that variable better be in my equation, because that's the whole point of using that variable. Right? So m. Abby.
What is the condition?
Condition is what's the equation that makes that true. So as you plug in the m or the x, the condition says this is what I'm going to do to x to spit out the answer. Okay, and this is real quick, as humans, this is like the easiest notation that we have come up with to talk about functions. So on the next example, what example are we on? Are we on 3? I'm going to write 3. Okay, evaluate function. Okay, so here it is. Here's my generic function called, oh, let's do easy one. Let's do 2 functions here. Here it is, f of x is equal to 3x minus 5. I'm going to write another function called g of t. And in science class, this is gravity and due to time, if we were actually using variables correctly here. So, second. No, this is just the variables themselves. G, little g is for gravity on Earth. Big G is gravitational field in the whole entire universe. T usually stands for time, but that's not the equation for gravity.
I have a question about that. If we were to put all of the mass together, would that change the mass amount?
Some weird property of like, oh, I'm gonna save this for later. Okay, you guys go for it. So f of 0, I want you guys to find that out first. G of -1, h of 4, all yours. Notice I'm naming the functions, right? No, I'll get to yours in a second. I'm not ignoring you. So notice what I do is I'm naming the function f. That means you're going to plug in a 0 for the f function f, right? So by the naming of functions, you tell me which one you're plugging into. Next is notice how easy the formula is, right? I mean, it's so easy, the fact that it's f of 0, right? I have all my notation in front of me. Then I notice that I plug in the 0 here, and then 3 times 0 is 0, minus 5 is a -5. Notice how it's actually clean notation. Not like when Descartes just figured this out. And it was not very clean for him. But I know what I plugged in, and I also know the output right in front of me, all of it. But we're trying to find out if x becomes a 0, what would f of 0 be? And the answer is -5.
Couldn't we write this as the function, or are we writing this as the function in the name of the function and then the variable that we're writing this function?
Or the number that we're plugging in for the variable.
And
Yeah.
Then
and then the output comes in. So sometimes you guys will see this right here. You guys will see it like this. This is where I'm saying the notation is very clean. Sometimes you see it just like this. Super clean notation. Look at that. I know what function I used. I know exactly what I plugged in, and I know exactly what the output was. So there it is. Okay, we're good. And I think you guys already finished with this one here. So Noah, to answer your question, is matter cannot be destroyed, created or destroyed?
well, but
Some weird thing like that?
Technically, you can create matter, so. And you can destroy it, you can.
This is the whole basis of science.
Well, no, you technically.
My dude.
This is a big argument to try to
You
make.
technically can, because the energy that you create with light is technically.
Where are we going with this?
Why does this matter? No pun intended. Why does this matter? I didn't mean it.
According to you didn't have a choice at that point.
I kind of had to.
It was funny. We didn't have it technically.
Also, if you split muons, so create a new muon just to have a partner, so you can actually create matter like that. It costs a lot of energy.
We're in math class.
I'm gonna stop for now. But fun question for your science teacher.
Which I've always thought of that as a weird property of muons.
Yeah, science is interesting. Okay, guys, real quick, D, we have to get through this here. So f of, oh, well, that's weird. Look at this. It's f of x plus 2. I take my variable, and I still want the variable to be there, but I want to be adding 2 to that variable all the time. Let's plug it in. Let's see. Notice for B, let's see, what I like to do, if you guys haven't noticed yet, whenever I plug in my variable, I always like to put parentheses on there because it kind of just separates it out from everything else. So then I can kind of just function through the process here. So
No, because
for B? No, this one is, so notice this is not a multiplication to G. This is actually input. You're saying that's what I'm inputting and I'm going to get an output of something. So not multiplication. Cool. F of x plus 2. This is funky. Let's go with it. So this is 3 times x plus 2. Notice whatever I have in that parenthesis, I put exactly in the parenthesis inside my condition. We're good? So I'm going to create another function, a totally different function that actually allows me to add 2 each time to my function. So how about, let's see, 3x, distribute the 3. I'm going to go with 3x plus 1. Are we good with 3x plus 1? So I've created another function that is 2 units more each time.
Wait, with that, can't we figure out exactly what x is?
We can. We'll do that a little bit later, yeah, but we can. Okay, next, and one more other piece here, something called piecewise functions here. Okay, we're getting you more complicated. Is this more complicated than Algebra 1?
No.
No, okay, that's
Because
cool.
because our brains understand it.
Do you even remember Algebra 1?
Never mind. I changed my answer because everyone disagrees with me.
Okay, piecewise functions. What is this? It means that we're going to take the function that we just had, but we're going to break it up into different functions at different times. Let's see if I can make this a little clear before we do that. So if you pay for your own cell phone bill, I see some people don't. But let's see, in the olden days, you only had a certain amount of minutes of talk time. I remember that. So after a certain amount of time, then you get a bill that's higher, right? I think nowadays it's like data, right? For some plans, it's data usage.
So for now, it seems to be mostly plans that have a certain amount of data or infinite data, or
and then either pay for the data or else you get.
Well, if you get infinite data, you pay like a certain amount of money.
Well, if you get infinite data, you just pay a monthly fee.
Yeah. For illustration purposes, you guys ready? So let's say you pay $50 a month for data usage on your phone, and then eventually 1, 2, 3, 4, 5. After again 5 gigabytes of data, notice then it's going to go like this. Notice your bill is going to change because now you're paying for the data usage. But notice, that's what I want you guys to see is, notice the one part, the function is one way, right? It's a straight line, it's a flat fee, right? And then all of a sudden at 5 gigabytes, it changes to do something else. Okay?
Can we
So
not have that instead, just like have it always the same price?
this is just for illustration purposes
No,
here
no,
of
no.
piecewise functions. Yes, you can have unlimited data. You're just pay whatever needs to be paid.
Also, like 5 gigabytes is not that much. You can't even send a picture with that.
Literally nothing. It's like that.
Let's go with it. So I'm going to put, oh, look at this, P for price. I'm going to put P for price. And then here's how we do a
Oh, no,
piecewise
6.
function.
No, sorry, you're right.
Yes.
That's okay. Piecewise function says this, for the first, I'm going to pay $50. And I'm going to do it for the first, 5 gigabytes. So X is less than 5. We're good. So up to 5 gigabytes, I'm paying $50. And let's say afterwards, I paid additional so much money. The only problem here with this, guys, real quick here, is if this linear line were extended down, right? Notice it actually will go down this way. Isn't that weird?
That's a money exploit.
But because we're not using the y-intercept here, we're good. So let me just kind of give the equation of this line. We're good. Let's say we pay an extra.
Let's find out how to get negative gigabytes.
1 second, no, 1 second. Let's say we pay an extra $10 per gigabyte, right? But then I need to account for this thing being all the way down here. We good? So let's say this was like -40. So I'm going to say for anything that's 5 or greater, I pay the extra price. We good? So this 40 has nothing to do with anything. It's just the fact that I need a linear line here, right? But once I hit 5, then I start using this line.
Isn't x less than and equal to 5 in both cases?
No, because good question, Noah. So you can't have that situation happening because now the x has to be only one spot. It can't be in 2 different spots because then you don't longer have a function. So could it be?
If you were to do 50. Wait, so would it be cheaper than? I'm confused.
This is not the equation for it. I'm just saying, as an equation, you write 2 different equations for when it separates from themselves. Okay, let's jam to the exercise problems here. So here it is, exercise 4. Same stuff, evaluate the function. Except these guys are now piecewise functions. So here it is, I have a big old function called f of x, and it's equal to function. We've got 5 minutes left here. How are we going to get through it? All right, so A, can you find for me that one? B, C, D, okay. So not each of those, but we got to figure out which one is being used when. Just kind of like our cell phone illustration, right? Up to 5, we're going to use the first one after 5. So this is very important right here. So it says that if x is less than or equal to 0, I'm going to use that equation. If x is between 0 and 4, I'm using this one. And if it's greater than or equal to 4, I'm going to use that one. We're good? So let's jam. So -1, which equation? Top, middle, or bottom?
Bottom. No.
It's the top one because.
Yeah, this one here, right?
Yeah.
Yeah, top one. First one, you can say first one from the top. So -1 squared plus 3, all yours. Answer is?
Yeah.
4. Are we good there? Boom. F of 3, which equation am I using? The middle one, right? Because now 3 is between 0 and 4. Answer is? The answer is 3, because it's whatever you plugged in, you plug in. We good? Cool. F of 4. Yeah, this one you got to be careful for, right? Because it depends on, that one says anything less than 4, right? So if it was 3.9, we would use the middle.
Less than or equal to 4.
Yeah, S equal to 4 is the last one. And F of 5?
Same one.
Same one. Yep, still the bottom, and the bottom is a constant function called 13. Okay. We're almost done with 1.4. We didn't get there yet, so homework is up to 37. I thought I would finish by now, but I guess we won't.
Okay,
Enjoy the rest of your day. See you guys on Wednesday. 1.3 homework right on the corner desk right there before you leave. And Noah, I need yours.
yes. Okay, so let's take 2 steps here.